The Wittig reaction is used to transform carbonyl groups into alkenes. Let's start by looking at a brief overview of this reaction. Start with a carbonyl group, which can be an aldehyde or a ketone. This is reacted with a phosphorus stabilized carb anion, and the result is the alkene. The way this adds, it removes this oxygen and replaces it with this. In this example, I used a ketone because it's easier to see over here what's going on. I'll label this side R prime and this just R. Looking at the ketone, these R primes didn't go anywhere, and this replaced the oxygen. So looking at it in more detail, let's begin with how to make this. Take triphenylphosphine. That's phosphorus bonded to 3 phenyl groups. It has a lone pair. We take this and we react it with an alkyl halide. Now the alkyl halide is going to give the alkyl group that is going to add over here. So you use an appropriate alkyl halide. This will undergo a substitution reaction to give this. It takes these electrons away, so there's a partial positive on the phosphorus. Using butyl lithium to remove one of the protons, this is a strong base, it gives this resonance structure. There's a positive charge on the phosphorus and a negative charge on the carbon. It's a carb anion. The other resonance structure is a double bond. I chose to use this resonance structure because, as we know, resonance structures, it's not one or the other, it's something in between. So there is going to be some positive character and some negative character on both of these things. And with this, it's easier to see that it's got nucleophilic capabilities. It's easier for me to remember. That's why I use that. So the next step is to add this to our carbonyl group, aldehyde or ketone. And here you can see it's easier to see that this is going to react like so. There's a partial positive, partial negative. A nucleophilic addition reaction to give this structure. Carbon, carbon, oxygen. This bond is broken. The electrons go up to the oxygen. Like so, there's a negative here. And there's still this positive on the phosphorus. These are going to be in close proximity with each other. So these electrons from the oxygen will be able to migrate over and form a new bond with the phosphorus, creating this square. Carbon bonded to oxygen, bonded to phosphorus, phosphorus bonded to carbon. The oxygen is a lot more electronegative than carbon. It would be ideal to have a double bond to the phosphorus and these two more equal bonds, these equally electronegative carbons to have another bond between them. So this is what happens. This bond transfers to the phosphorus and this one transfers to the carbon. This breaks, new bonds are formed. This happens at the same time. And the result is an alkene. These are all on the same side. Thinking back to here, this transferring over to here. And the oxygen is transferred to the phosphorus. So it's basically this switches for this.